this lecture, today actually I will see the Rouche's theorem. At first, I will see one question of residue theorem. In my previous video, I had discussed residue theorem briefly, and in my previous video, I had discussed many questions of residue theorem. Today, I will discuss one question just as a review of residue theorem. Then I will discuss our main goal of this lecture, Rouche's theorem. Here, cot pi z over z minus I whole square, and C is the contour, and the contour is 4x square plus y square equal to 2. Cot pi z over z minus I whole square means this is equal to cos pi z over sin pi z minus I whole square, and sin pi z equal to 0 at z equal to n, and this is equal to 0 z equal to I. And here the contour is 4x square plus y square equal to 2, and z equal to I means x equal to 0, y equal to 1. This is satisfy the contour. Here x equal to 0, y equal to 1 satisfy the contour. This is inside the contour. And z equal to n means n equal to 1, 2, 3, so on. That means x equal to n, y equal to 0. Also 0. If we consider n equal to 0, then this means x equal to 0. This is satisfy this curve, this inside this curve when x equal to 0. But if you consider x equal to 1, this means 4 and y equal to 0, which is greater than 2. This is outside of this contour. That means only z equal to 0, I and I double pole here be the inside of the circle. I hope my all viewers have understood clearly. For z equal to 0, the residue theorem is 2 pi I z minus 0. Here cot pi z over z minus cot pi z over z minus I whole square. Then for this is for the 0 point, and for I here double pole, and this is equal to 1 over 1 factorial ddz of cot pi z at z equal to I, and this value is equal to 2 pi I. Here ddz of cos pi z means minus pi cosec square pi z at the point z equal to I. This is equal to minus pi 1 over sines pi square I, sin square pi I, and sin square pi I means this is minus pi sin hyperbolic pi, sin square hyperbolic, sin hyperbolic square, sorry, minus pi sin hyperbolic square pi. Okay, and here this is the 0 over 0 from here. If you put z equal to 0, then this value is minus I square means minus 1. then written this as z cos pi z over sin pi z. This value is plus 0 over 0 from, and this value is just calculate in outside, minus z cos pi z over sin z, sorry, sin pi z, sin pi z, this is 0 over 0 from, so this is cos pi z, here minus z minus z sin pi z plus cos pi z. Now put the value z equal to 0, then this value would be, here this value would be 0 and cos pi z means 1, this value would be minus 1. Here I have done one wrong. Here derivative of sin pi z is cos pi z times pi. Here derivative of cos pi z is sin pi z times pi. So this value is 0 and this value is 1 and this value is 1, and this value would be minus 1 over pi. That means this value is minus 1 over pi minus this part, and here 2 pi I. I hope my all viewers have understood. So notice the option. The option first 0, this is wrong. Minus 2 pi I, this is also wrong. This is right option, this is wrong option. I hope my all viewers have understood this question. Okay. See the Rouche's theorem. This is the goal of today's lecture. If f and g are two holomorphic functions inside closed contour C, and if modulus of gz less than modulus of fz on the contour C, then f and f plus g always have same number of 0 inside C, and each 0 is counted as many as counted multiplicity. Okay. F and f plus g always have same number of 0 if this is satisfied with counted multiplicity, where f and g both holomorphic function inside the contour C. As for example of Rouche's theorem, at first choose fz and gz from the given function, then check whether mod gz less than fz, mod gz over fz less than 1. Then by Rouche's theorem we can tell fz and fz plus gz have same number of zeros inside the contour C. As for example theorem, prove that z to the power 7 plus minus 5z cube plus 12, this polynomial on the contour mod z equal to 1 has no zeros. On mod z equal to 1, mod z to the power 7, this value is 7, minus 5 mod minus 5z cube, this value is 5, and this 12, this value is 12. Here highest value is 12. Therefore consider fz equal to 12 and gz equal to z to the power 7 minus 5z cube. Then gz over fz, this value is z to the power 7 minus 5z cube divided by 12, and this is less than equal to z to the power 7 mod z to the power 7 plus minus 5z cube over 12, and on mod z equal to 1, this value is 1 plus 5 over 12, this value is equal to 1 by 2 and 1 by 2 less than 1. Since this is less than 1, therefore by Rouche's theorem we can tell fz and fz plus gz has same number of 0. By Rouche's theorem we can tell fz and fz plus gz have same number of zeros. Here fz equal to 12, which has no zeros, on mod z equal to 1. So fz plus gz by Rouche's theorem we can tell has no zeros. Okay. Determine the number of zeros including the multiplicity of the polynomial z to the power 4 minus 2z cube plus 9z square plus z minus 1 in mod z less than 2. On the contour mod z equal to 2, here z to the power 4 minus 2z cube plus 9z square plus z minus 1, this value would be 16. This value also 16. Sorry, this z cube. 16. 9z square means 4. 36. This is 2 and this is minus 1. The highest value is 36 and this value 16 plus 16 plus 2 plus 1, this is 35, and 35 is less than 36. That means f of z equal to 9z square and gz equal to z to the power 4 minus 2z cube plus z minus 1. And notice mod gz over mod fz, this value is z to the power 4 minus 2z cube plus z minus 1, here 9z square, this value is less than 1. Therefore, by Rouche's theorem, fz and fz plus gz has same number of zeros. And since fz equal to 9z square, therefore this has 2 zeros inside mod z less than 2. Therefore the given function z to the power 4 minus 2z cube plus 9z square plus z minus 1 equal to 0 has 2 zeros. Inside mod z less than 2. Next question had come. CSR net 2023 exam. The question is z to the power 100 minus 15 z to the power 30 plus 14 plus 40 z to the power 10 plus 6z plus 1 have in the appendix mod z less than 1. How many roots does the polynomial? Here I will apply Rouche's theorem. On mod z equal to 1, highest degree is, this would be 50, highest degree is z to the power 30. Therefore, fz equal to 50 z to the power 30 and zz equal to rest term z to the power 100 minus 40 z to the power 10 plus 6z plus 1. And notice zz over mod gz over mod fz, this value is less than 1. Therefore, by Rouche's theorem we can tell fz and fz plus gz have same number of zeros. And since fz equal to 50 z to the power 30, that means number of zeros is 30. Therefore, in this appendix, since this is the gz and by Rouche's theorem, since fz and gz has same number of zeros, therefore 30 number of zeros. This is the right option. Okay. D equal to mod z belongs to C such that a mod z less than 1. Here f mapping from D to C defined as fz equal to z minus 25z cube plus z to the power 5 over 5 factorial plus z to the power 7 over 7 factorial, z to the power minus plus z to the power 9 over 9 factorial minus z to the power 11 over 11 factorial. In mod z equal to 1, highest degree is 25z cube. Therefore, fz equal to minus 25z cube and zz equal to z plus z to the power 5 over 5 factorial minus z to the power 7 over 7 factorial plus z to the power 9 over 9 factorial minus z to the power 11 over 11 factorial. And notice modulus of fz over gz, this value is always less than 1. Since this value is less than 1, so by Rouche's theorem we can tell on mod z equal to 1, fz and fz plus gz have same number of 0. Since fz equal to 25z cube, therefore fz have three zeros. Therefore, Option 1 is a right option. In D, f has 3 zeros. Next, f has 0 in U. Here, half less than mod z less than 1. Here, when on D means z equal to 1, degree of zeros is 3. I have got few minutes ago. When mod z equal to half, this value equal to half, then this is mod z 25 over 8. This is 1 over 5 factorial times 2 to the power 5. This is 1 over 7 factorial times 2 to the power 7. This is 1 over 9 factorial 2 to the power 9. This is 1 over 11 factorial 2 to the power 11. Here maximum degree is also here. Therefore, since maximum degree is this, so fz equal to minus 25z cube, and fz have, similar to before, 3 zeros. Therefore, since we have to find in this region, here 3 zeros, here 3 zeros, then 3 minus 3 equal to 0. Therefore, no zeros. But in the option 2 given, f has 1 0 in U. That means this is wrong option. That means only P is Q true and Q is false. A option is right. The number of zeros with counting multiplicity Pz equal to 3z to the power 5 plus 2iz square plus 7iz plus 1. In the analysis, mod z belongs to C such that 1 less than mod z less than 7. Number of zeros, and this question had come GATE 2021 exam. On mod z equal to 1, this value is 3, 2iz square, mod z equal to 1 is 2 1 whole square, this value is 1, 3 1 2 7 1. Here highest degree is 7, so fz equal to 7iz and other term is gz, similar to before. Since fz has 1 zeros, since degree of z is 1, therefore on mod z equal to 1, number of zeros is 1. On mod z equal to 7, first 3 into 7 to the power 5, then 2 into 7 square, mod z equal to 7, 2 into 7 square, 7 into 7, here 1, and maximum degree is 5, 3 into z to the power 5. That means this is fz. Fz equal to 3z to the power 5, and degree of f is 5, so number of 0 is of 5 order. Number of zeros in the analysis 1 less than mod z less than 7 is 5 minus 1, this value is 4. That means this answer would be 4. Today I will stop here. In my next video, I will discuss conformal mapping. Actually, conformal mapping is very important for higher study. Okay? See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.